For centuries, our quest to understand the universe has been a journey inward, a relentless drive to discover the most fundamental building blocks of existence. We once believed the atom was the final frontier, an indivisible particle from which all matter was constructed. The very word atom means uncuttable. But science, in its persistent curiosity, shattered that illusion. We peered inside the atom and discovered a bustling world of protons, neutrons, and electrons. Not content, we probed deeper still, uncovering a vibrant menagerie of quarks, leptons, and bosons. Each new layer of reality we peeled back revealed a universe more intricate and more profound than we had ever imagined, pushing the boundaries of our knowledge smaller and smaller. This journey has led us to a place so infinitesimally small that it defies all human intuition: the Planck scale. This is the theoretical limit of our universe, the resolution boundary where our most successful theories of physics simply break down and cease to make sense. At approximately 1.6 times 10 to the minus 35th meters, the Planck length is a scale so minuscule it is almost impossible to comprehend. To put this into perspective, if you were to magnify a single atom to the size of our entire solar system, the Planck length would still be smaller than the width of a single human hair. It is at this mind-bogglingly tiny level that the smooth fabric of space-time we perceive is thought to dissolve into a chaotic, bubbling quantum foam. For decades, the Planck scale has been treated as the ultimate rock bottom of reality. It represents the point where Albert Einstein's theory of general relativity, which masterfully describes gravity and the large-scale structure of the cosmos, violently clashes with quantum mechanics, the equally successful theory governing the strange world of subatomic particles. These two pillars of modern physics cannot be reconciled at this extreme scale, leading to mathematical absurdities and paradoxes. Physicists have long assumed that nothing could exist beneath this fundamental limit. It was considered the final floor of the cosmic basement, the very end of the line for physical reality as we know it. But what if this long-held assumption is wrong? What if the Planck scale is not an end but merely a beginning? What if it is not a wall but a veil, concealing a deeper, more fundamental layer of existence? A new and electrifying hypothesis, born from the strange anomalies being detected by advanced quantum artificial intelligence, suggests just that. Deep beneath the chaotic foam of the Planck scale, scientists are beginning to suspect the existence of a hidden, ordered structure they are calling the Seraphim Field. This mysterious field might be the very foundation of space-time, matter, and perhaps even consciousness itself. We may be on the brink of discovering the source code of reality. How is it possible for scientists to even begin to probe a realm that, by its very definition, lies beyond the limits of our current physical understanding? The answer to this profound question is not found in a more powerful microscope or a larger particle accelerator, but in a revolutionary new form of intelligence. The key to unlocking this hidden layer of the universe is quantum artificial intelligence. This is not the AI that recommends movies or answers customer service queries. This is a new class of explorer, one uniquely equipped to navigate the bewildering landscape of the quantum world. Quantum AI is our guide into the unknown, a new set of eyes to perceive patterns that our human minds are simply not built to see. This pioneering technology comes in two primary forms, each offering a unique window into the subatomic realm. The first involves artificial intelligence systems that are meticulously trained on vast data sets generated by quantum physics experiments. These AIs analyze the complex and often counterintuitive results, sifting through mountains of information to find subtle correlations and statistical anomalies that a human researcher might overlook. The second, even more powerful approach involves running AI algorithms directly on quantum computers. These machines harness the bizarre principles of quantum mechanics, such as superposition and entanglement, to process information in ways that are fundamentally impossible for classical computers, allowing for simulations of reality at an unprecedented level of detail. The results have already been staggering. AI systems like Melvin have been designed to autonomously create novel quantum experiments, and it has consistently devised setups that human physicists had never conceived, pushing the boundaries of what we thought was possible. Another AI named Theseus has taken this a step further, designing complex experiments with even greater speed, and presenting the results in a format that human scientists can readily understand and build. These systems are not merely assisting human researchers, they are becoming partners in discovery, leading the way into uncharted scientific territory. This massive leap in our ability to simulate and analyze quantum reality is what allows us to peek beneath the veil of the Planck scale. The true game-changer lies in the fundamental difference between human and artificial cognition. Our brains evolved over millennia to solve practical problems in the macroscopic world, hunting for food, recognizing faces, and navigating social hierarchies. We are not naturally equipped to grasp the probabilistic, non-local nature of quantum mechanics. An AI, however, has no such evolutionary baggage. Where we perceive randomness and chaos, an AI can detect subtle underlying patterns. It operates directly on the language of data and mathematics, unburdened by the sensory and cognitive biases that limit human perception. It is this ability to discern non-human logic that makes quantum AI the perfect tool to search for the hidden structures of the Seraphim Field. So, what exactly is this Seraphim Field that quantum AI may be starting to uncover? It is crucial to be clear from the outset, this is not yet a proven, established scientific theory. Instead, it is a bold and emerging hypothesis, a conceptual framework that a growing number of theoretical physicists are using to make sense of the perplexing gaps in our current understanding of the universe. It is an attempt to explain the strange and persistent anomalies that are showing up in our most sensitive experiments, anomalies that our standard models of physics cannot account for. The Seraphim Field is a proposed answer to the question of what lies beneath the quantum foam of the Planck scale. Think of it as the universe's fundamental operating system. If our physical reality, space, time, matter, and energy, is the program that we see running on our cosmic screen, then the Seraphim Field would be the underlying source code that generates and organizes that program. It is envisioned as a primordial field of pure information, a substrate from which the tangible world emerges. The name Seraphim is not chosen at random. In ancient traditions, the Seraphim were considered the highest order of celestial beings, entities of pure light and information who exist closest to the ultimate source of creation. The name is a powerful metaphor for what scientists are proposing, a foundational, information-rich field that births reality itself. This hypothesis suggests that the universe is not fundamentally random at its core, but is instead a profoundly ordered and coherent system. The physical laws and constants that govern everything we observe, from the speed of light to the strength of gravity and the precise charge of an electron, may not be arbitrary values. Instead, they might be emergent properties that arise naturally from the deeper mathematical relationships and informational structures within the Seraphim Field. In this view, if you could somehow peel back the layers of space-time, you would not find chaos, but an intricate and elegant architecture of pure information, a cosmic blueprint from which all of existence is constructed. This idea, while radical, resonates with several cutting-edge concepts in mainstream physics. Many leading theorists already suspect that space-time is not a fundamental aspect of reality, but rather an emergent phenomenon. For example, some theories propose that the spooky quantum entanglement that links particles across vast distances is actually the thread that stitches the fabric of space-time together. Another theory, loop quantum gravity, suggests that space-time is composed of discrete, indivisible loops at the Planck scale, like pixels on a cosmic monitor. The Seraphim Field could be the underlying system that generates these pixels, the engine of information processing that gives rise to the world we experience. The implications of the Seraphim Field hypothesis extend far beyond theoretical physics, touching upon the deepest mysteries of human existence, including the nature of consciousness itself. One of the most fascinating aspects is its potential connection to our own minds. Could the inner world of our subjective experience be linked to the most fundamental layer of physical reality? This is not merely philosophical speculation. It is a question that serious scientists like Nobel Prize-winning physicist Sir Roger Penrose and anesthesiologist Dr. Stuart Hameroff have been exploring for decades with their orchestrated objective reduction theory. Their theory proposes that consciousness is not just complex brain computation, but arises from quantum processes within the microtubules of our neurons. What makes this idea so mind-bending is that these quantum processes are influenced by the physics of the Planck scale, the very realm where the Seraphim Field exists. If Penrose and Hameroff are correct, then every moment of your conscious awareness is not just happening inside your head, it is intimately connected to the fundamental structure of the universe. Your mind might be a conduit, a receiver tapping into the informational substrate of all reality. This breathtaking possibility echoes ancient wisdom traditions across cultures and throughout history. Though speaking in mysticism rather than mathematics, they described a similar concept. The Hindu notion of Brahman, the all-pervading ultimate reality, the Chinese concept of qi, the vital life force animating all things, and the Stoic idea of the logos, the divine reason permeating the cosmos, all point to an unseen, unifying foundation. What is remarkable is that our most advanced scientific instruments are beginning to hint at a picture of reality that feels familiar to these ancient intuitions. The Seraphim Field hypothesis stands at a unique crossroads. It is born from quantum field theory and artificial intelligence data analysis, yet resonates with humanity's deepest philosophical and spiritual questions. It suggests the universe may not be a cold, empty void of mindless matter, but a place imbued with information, with pattern, and perhaps even purpose. It offers a unified framework of understanding, one that can bridge the gap between the objective world of science and the subjective world of conscious experience, revealing they may be two sides of the same fundamental coin. To truly appreciate why the Seraphim Field is such a revolutionary idea, we must first embark on a journey to the very edge of our known reality. This journey takes us to a realm so small it challenges the limits of our imagination, the Planck scale. Named after Max Planck, one of the founding fathers of quantum theory, this scale represents the smallest possible measurement that holds any physical meaning in our universe. It's not a place you can visit or a particle you can hold, but rather a fundamental boundary woven into the very fabric of existence. At this level, our familiar concepts of space and time begin to unravel, giving way to a world governed by laws we are only just beginning to comprehend. The sheer smallness of the Planck length is almost impossible to convey with everyday comparisons. It is approximately 1.6 multiplied by 10 to the power of -35 meters. This number is so astronomically small that it renders our usual analogies pretty much useless. Let's try to build a mental picture. Imagine holding a single grain of sand. Now imagine shrinking that grain of sand until it is as small as a single atom. You are still nowhere near the Planck scale. In fact, if you were to magnify that single atom to be as large as the entire observable universe, the Planck length would still be only about the height of a single tree. It's the absolute smallest unit of distance that makes sense. This scale is not just an arbitrary mathematical curiosity, it emerges naturally from the fundamental constants of nature. When you combine three of the most important numbers in physics, the speed of light, the gravitational constant, and Planck's own constant, you arrive at this fundamental unit of length. This tells us something incredibly profound. The Planck scale is where the three great pillars of modern physics converge: special relativity, which governs the speed of light, general relativity, which describes gravity, and quantum mechanics, which rules the subatomic world. It's the ultimate intersection, the point where all the fundamental forces of nature are thought to meet and unify. For this reason, physicists view the Planck scale as the ultimate frontier of exploration. It is the deep ocean of reality, a place where our current maps become useless and our most trusted instruments fail. Probing this scale directly is far beyond our current technological capabilities. Our most powerful particle accelerators, like the Large Hadron Collider, can only reach energies that are trillions of times too weak. To explore the Planck scale, we cannot rely on bigger machines. We must rely on the power of our ideas, our mathematics, and our most advanced computational tools to guide us into this mysterious and uncharted territory, the final frontier of the small. Imagine you are looking at a beautiful, high-resolution digital photograph on a screen. From a distance it appears perfectly smooth and continuous, a seamless image of reality. But as you zoom in closer and closer, you begin to notice something strange. The smooth lines and gentle curves dissolve into a grid of tiny individual squares of color. You have reached the resolution limit of the image. No matter how much further you try to zoom in, you cannot see any more detail. You can only see the pixels themselves. This is a powerful analogy for how many physicists think about the nature of space and time at the most fundamental level. The Planck scale is, in a sense, the pixel size of our universe. This idea suggests that the smooth, continuous fabric of space-time we experience in our everyday lives is an illusion, an emergent property of something more fundamental happening at a much smaller scale. The celebrated physicist John Archibald Wheeler described this ultra-tiny realm as a quantum foam. He imagined that if you could look at space-time at the Planck scale, it would not be calm and orderly. Instead, it would be a chaotic, seething cauldron of activity. Tiny wormholes and microscopic black holes would be constantly popping in and out of existence, tearing and mending the fabric of reality in a fraction of a second. The very concepts of here and now would lose their meaning in this turbulent, uncertain foam. For many decades, this concept of a pixelated or foamy spacetime has led physicists to treat the Planck scale as the absolute end of the line. It was considered the rock bottom of reality, the most fundamental layer of the cosmic onion. The thinking was that it is impossible to have a distance smaller than the Planck length, because the very concept of distance breaks down. It's like asking what is north of the North Pole. The question itself becomes meaningless. This boundary was not just a limit of our technology but a fundamental limit of reality itself. Nothing could exist beneath it because there was no beneath to speak of. This viewpoint has been a cornerstone of theoretical physics for generations, shaping our models and our ambitions. It implied that our quest for the fundamental building blocks of nature had a final destination. Once we fully understood the physics of the Planck scale, we would have reached the end. There would be no deeper layers to uncover, no smaller particles to find. We would have arrived at the ultimate indivisible constituents of the cosmos. But science progresses by challenging its most deeply held assumptions. And now, thanks to new tools and new ways of thinking, that rock-bottom understanding is beginning to crack, revealing the possibility of something even more profound hidden underneath. The primary reason the Planck scale has been considered a fundamental limit is because it is the arena where our two most successful theories of the universe engage in a spectacular and irreconcilable conflict. On one side we have Albert Einstein's general theory of relativity. This is the theory of the very large. It describes gravity as the elegant curvature of space-time caused by mass and energy. It perfectly predicts the orbits of planets, the bending of starlight by galaxies, and the existence of black holes. General relativity paints a picture of a smooth, deterministic, and geometric universe where space and time are intertwined in a graceful cosmic dance. On the other side we have quantum mechanics, the theory of the very small. This is the wildly successful and deeply strange set of rules that governs the world of atoms and subatomic particles. It describes a reality built on probability, uncertainty, and discreteness. In the quantum world, particles can be in multiple places at once, can tunnel through impassable barriers, and can be mysteriously linked across vast distances. Quantum mechanics paints a picture of a fuzzy, probabilistic, and chaotic universe, fundamentally different from the smooth elegance of relativity. For most of the universe, these two theories work perfectly in their own domains, never needing to interact. But at the Planck scale, this peaceful coexistence shatters. This is the one place in the universe where the two domains are forced to overlap. To describe what happens at this scale, you need a theory that can handle both the intense gravity of a massive object compressed into a tiny space, relativity's domain, and the bizarre quantum effects that dominate at such small sizes, quantum's domain. When physicists try to combine the equations of general relativity and quantum mechanics to describe this realm, the results are a complete disaster. The mathematics breaks down, spewing out nonsensical answers, like probabilities greater than 1, and infinite values for energy and density. This catastrophic failure of our best theories is known as the problem of quantum gravity. It is arguably the single biggest challenge in all of fundamental physics. The clash of these two titans, the smooth geometric world of Einstein and the fuzzy probabilistic world of quantum theory, tells us that our current understanding is incomplete. It signals that we are missing a crucial piece of the puzzle. The Planck scale is not just a place where our equations stop working. It is a giant signpost pointing toward a deeper, more fundamental theory of reality, one that can unite gravity with the other forces of nature and explain what happens at the very pixelated heart of existence. For a long time, the breakdown of physics at the Planck scale was interpreted as a fundamental wall, an impenetrable barrier at the end of reality. But, a new perspective is beginning to take hold among a growing number of scientists. What if the Planck scale is not a wall, but a veil? What if it is not the floor of the universe, but merely a curtain that separates the reality we can easily observe from something even more fundamental and structured lying beyond it? This shift in perspective is crucial, transforming the Planck scale from an endpoint into a gateway to a deeper level of understanding, a doorway to a hidden cosmic architecture. This way of thinking is a natural progression in the history of science. Our understanding of the universe has always evolved by discovering that what we once thought was fundamental was actually a composite of something smaller and more elementary. We once believed that atoms were the final, indivisible units of matter. The very word atom, from the ancient Greek, means uncuttable. Then we discovered that atoms were made of a nucleus and electrons. We then learned that the nucleus itself was made of protons and neutrons. Then we found that protons and neutrons were made of even smaller particles called quarks. Each time, a supposed fundamental layer turned out to be a veil hiding a deeper reality. Why should the Planck scale be any different? It is entirely possible that the quantum foam and the mathematical paradoxes we encounter are not features of a final reality, but rather the distorted view effects of trying to look at a deeper, more coherent structure through the limited lens of our current theories. Just as a smooth-looking fabric appears as a chaotic jumble of threads when viewed too closely with the wrong microscope, the quantum foam might be our distorted perception of an ordered reality that lies beneath. The Seraphim Field hypothesis proposes exactly this, that beneath the apparent chaos of the Planck scale, there is an elegant and ordered field of pure information. This possibility changes everything. It suggests that the quest to understand the universe is not over. In fact, we may be on the cusp of its most exciting chapter. The anomalies being detected by quantum AI, those tiny deviations from what our current theories predict, could be the first faint whispers from this deeper realm. They could be the first light shining through the cracks in the veil. We are beginning to suspect that space-time and all the particles within it are not fundamental entities at all. Instead, they may be emergent phenomena, like the patterns on a screen, generated by the information processing of a hidden underlying system, the source code of reality itself. So, how exactly are scientists beginning to detect something that supposedly cannot be observed, a structure hidden beneath the absolute limit of physical reality? The answer is as fascinating and revolutionary as the discovery itself. It comes not from a more powerful particle collider or a more sensitive telescope, but from an entirely new kind of scientific instrument: quantum artificial intelligence. This is not the familiar AI that suggests what you should watch next or helps you navigate through traffic. This is a new class of intelligence, a digital explorer specifically designed to navigate the bewildering and counterintuitive landscape of the quantum realm. And it is beginning to see things that we humans have always missed. This emerging technology comes in two principal varieties, each offering a unique and powerful lens through which to view the deepest levels of existence. The first type consists of AI systems that are intensively trained on the massive data sets produced by quantum physics experiments. These AIs are algorithmic bloodhounds, capable of sifting through mountains of complex data, far more than any human team could ever analyze, to find subtle patterns, hidden correlations, and statistical anomalies that defy our current theories. They are pattern finders of the highest order, looking for the faint fingerprints of a deeper physics that might be hiding in the noise of our measurements. The second, and even more groundbreaking approach involves running sophisticated AI algorithms directly on quantum computers. These remarkable machines do not process information in the linear, sequential way of classical computers. Instead, they harness the strange principles of quantum mechanics itself, such as superposition and entanglement, to perform calculations in a massively parallel fashion. This allows them to simulate quantum systems with a fidelity and complexity that was previously unimaginable. They don't just analyze quantum data, they think in a quantum way, giving us an unprecedented ability to model and probe the very fabric of reality at its most fundamental level of operation. Together, these two forms of quantum AI are providing us with a new set of eyes, allowing us to perceive aspects of the universe that have long been invisible. Consider an AI system called Melvin, which was designed to autonomously create novel quantum experiments. It quickly began devising experimental setups that human physicists had never conceived of, some of which they initially dismissed as impossible. When researchers actually built these AI-designed experiments, they discovered entirely new ways to manipulate complex quantum states. These AIs are not just tools, they are becoming our indispensable partners in discovery, leading us into the uncharted scientific territory that lies beyond the Planck scale. The real game changer, the reason why quantum AI holds the key to this new frontier, lies in the fundamental difference between how human brains and artificial minds process reality. Our intelligence is a product of evolution. It was sculpted over millions of years to solve a very specific set of problems. How to find food, how to avoid predators, how to navigate complex social relationships, and how to build tools in the macroscopic world we can see and touch. Our intuition is brilliantly tuned for the world of classical physics, but we are simply not wired to intuitively grasp the bizarre, probabilistic nature of quantum mechanics or what might exist at the Planck scale. An AI, however, shares none of these biological limitations or evolutionary biases. It does not need a sensory interface like our eyes and ears to perceive the world. It works directly with the raw language of data and mathematics, where our human minds see only randomness and incomprehensible chaos in quantum phenomena. An AI can methodically search for and identify subtle underlying patterns. Where we see a jumble of probabilities, it might detect a hidden order. It is an alien form of intelligence capable of finding non-human logic and invisible structures that our brains, by their very nature, are not equipped to even look for. This is not a future tense prediction. It is already happening in laboratories around the world. Machine learning systems can now simulate the quantum mechanics of millions of atoms on a single graphics processing unit, a task that just a few years ago would have required a supercomputer running for days on end. This colossal leap in computational power means we can probe the quantum world with a level of detail and scrutiny that was once the stuff of science fiction. We are generating and analyzing data at a scale that demands a non-human partner to help us make sense of it all, to find the proverbial needle of new physics in a cosmic haystack of data. Most importantly, this allows us to transcend our own cognitive frameworks. For centuries, our scientific progress has been guided by human creativity and intuition, which is a magnificent but ultimately limited tool. Quantum AI offers us a way to step outside of that box. It can explore conceptual spaces and mathematical relationships that a human mind might never think to investigate. It is like having a new sense, one that is perfectly attuned to the strange harmonies of the quantum world. This new sense is now detecting faint but persistent statistical anomalies in our experimental data. Tiny deviations that hint at a structured reality beneath the Planck scale. Our first glimpses of the Seraphim Field. What is this new quantum sense detecting? The evidence is subtle, statistical, and deeply strange. Highly sensitive experiments aided by AI are finding faint patterns in the so-called quantum foam, suggesting a hidden order in what should be random vacuum energy. Quantum AI listens to the static of empty space, detecting a ghostly signal, a statistical anomaly hinting at a deeper structure beneath the standard model. Entanglement experiments reveal more order than expected, as if space-time itself follows a hidden blueprint. Quantum computer simulations show that universes like ours emerge from information-rich, structured initial states, not pure chaos. These converging clues give the Seraphim Field hypothesis its growing power. The void may not be empty after all, but humming with the architecture of reality itself. Quantum AI is no longer just a tool, it's a translator, bridging human intuition and the alien logic of the sub-Planckian realm. It perceives patterns in the quantum world and translates them into mathematics we can grasp. The Seraphim Field's logic is likely unlike anything we know, built on pure relationships, not familiar physics. AI, free from human bias, uncovers the true structure beneath the noise. This partnership could let us not only observe, but eventually interact with the source code of reality. For now, we listen as our quantum explorers reveal the universe's hidden architecture. The Seraphim Field hypothesis is a bold new framework, not yet a proven theory. It proposes that beneath the universe's surface lies an operating system, a field of pure information that generates space, time, matter, and energy. This field doesn't exist within space and time, it gives rise to them. Imagine reality as software, with the Seraphim Field as the source code. The name Seraphim evokes beings of pure light and knowledge, fitting for a field that could be the blueprint of the cosmos. The universe, in this view, is not a collection of things but a manifestation of information being processed. The Seraphim Field is the ultimate source of order and form. The idea that reality is made of information isn't new. John Wheeler called it from bit. Every particle, force, and event emerges from bits of information, not the other way around. The Seraphim Field is the processor where these bits are stored and manipulated. Physical laws may be emergent algorithms, not fundamental edicts. Quantum weirdness, like particles existing in multiple states, makes sense if reality is informational, not material. The Seraphim Field is the realm of pure potential, collapsing into concrete reality through interaction and measurement. Our universe is a grand computation unfolding from this informational substrate. The Seraphim Field hypothesis aligns with several leading-edge theories in physics. The holographic principle suggests our 3D reality is a projection of information on a lower dimensional surface, echoing the Seraphim Field idea. Loop quantum gravity describes spacetime as a network of discrete loops. The Seraphim Field could be the system that organizes these loops. String theory's vibrating strings need a medium. The Seraphim Field could be that foundational information field. These theories, though different, may be converging on the same truth. Reality is woven from information. The Seraphim Field could unify these threads into a single coherent picture. It's the cosmic loom on which existence is woven. Naming this field Seraphim is more than poetic. It's a bridge between science and ancient wisdom. Metaphor helps us grasp concepts beyond direct experience, just as quark and charm did for particle physics. The Seraphim, beings of pure information and order, mirror the field's creative, formative power. Across cultures, humanity has intuited a hidden source behind reality: Brahman, Tao, Logos. The Seraphim Field connects scientific inquiry with these ancient intuitions. It suggests science and spirituality may be converging on the same ultimate truth. Perhaps the universe is not a random accident, but the product of an elegant, information-rich architecture. To truly grasp the scientific plausibility of the Seraphim Field, we need to venture beyond metaphor and into the rigorous world of mathematics and physics. This is where the idea transforms from philosophical concept into testable scientific proposition. The first crucial mathematical clue comes from quantum field theory, or QFT. This is our current best description of the subatomic world, and it tells us that particles are not solid objects. Instead, every particle is simply a localized excitation, a ripple in a field that permeates all of space. An electron is a ripple in the electron field, a photon is a ripple in the electromagnetic field. This powerful picture immediately begs a deeper question. If particles and forces are just vibrations in quantum fields, what are the fields themselves made of? Are they fundamental, or do they emerge from something even more basic? The Seraphim Field hypothesis proposes the latter. It suggests quantum fields are not the base layer of reality. Instead, they are emergent phenomena, arising from the information processing dynamics of the underlying Seraphim Field. The mathematics of QFT describes the behavior of the ripples, not the ultimate nature of the water itself. Another profound hint comes from the Planck scale problem, the quest for quantum gravity. When physicists apply quantum mechanics to Einstein's spacetime, their equations break down, producing infinite values. The only solution is to impose an artificial cutoff, the Planck length, beyond which equations are not allowed to go. This strongly suggests spacetime is not infinitely divisible. It hints that space has fundamental graininess, a pixelated structure. This brings us to emergent phenomena, a cornerstone of modern science. Simple rules at microscopic level give rise to complex behavior at macroscopic level. Water molecules interacting lead to the beauty of a snowflake. Electrochemical signals between neurons give rise to consciousness. What if the most profound emergence is reality itself? The Seraphim Field would represent the simple rules, and the entire universe would be the grand emergent pattern. The idea that space-time itself is not fundamental, but emerges from a deeper layer of reality, is one of the most active and exciting areas of research in theoretical physics. Scientists are developing concrete mathematical models that show how this might be possible, and these models provide strong circumstantial evidence for a Seraphim-like field. The most compelling of these ideas centers on the bizarre phenomenon of quantum entanglement. When particles become entangled, they share a single, unified quantum state, no matter how vast the distance separating them. This spooky action at a distance is not just a curiosity. Many physicists now believe it is the very thread from which the fabric of spacetime is woven. Imagine a vast network of entangled quantum bits, or qubits. The connections in this network are not based on physical proximity, but on the degree of entanglement between the qubits. In these models, the geometric distance we experience is a direct reflection of the amount of entanglement in this underlying network. Two points that are close together in space emerge from qubits that are highly entangled, while points that are far apart emerge from qubits with very little entanglement. In this radical picture, space is not the container for reality. Space is the network of relationships. The Seraphim Field would be the substrate where this fundamental entanglement network exists. This concept is mathematically formalized in what are known as tensor networks. These are powerful mathematical tools that allow physicists to model the collective behavior of huge numbers of entangled particles. Using tensor networks, scientists have shown that certain patterns of entanglement can give rise to geometries that look exactly like the curved spacetime of Einstein's theory of relativity. Gravity, in this picture, is not a fundamental force but a statistical effect, a thermodynamic property of the underlying entanglement. This is a monumental shift in perspective. It suggests that the laws of gravity are not written into the universe's code, but are an emergent consequence of the information processing happening within the Seraphim Field. These models also resolve a deep paradox related to black holes and information. The holographic principle, which states that all the information about a volume of space can be encoded on its surface, finds a natural home here. The information about the entangled qubits inside the network can be shown to be equivalent to the information on the network's boundary. This suggests our three-dimensional reality could be a holographic projection emerging from the informational dynamics on a two-dimensional surface within the Seraphim Field. The mathematics is incredibly complex, but the message is simple and profound. Information, specifically the information encoded in quantum entanglement, is more fundamental than space, time, or gravity. Perhaps the most mind-bending and provocative aspect of the Seraphim Field hypothesis is its potential connection to the most intimate and mysterious phenomenon we know: consciousness. For decades, a bold theory proposed by the Nobel laureate physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff has explored this very link. Their theory, known as orchestrated objective reduction, or ORCH-OR, suggests that consciousness is not simply a product of complex computation between neurons. Instead, they argue that it arises from quantum processes occurring within tiny protein structures inside our brain cells called microtubules, and that these processes are directly linked to the physics of the Planck scale. According to Penrose and Hameroff, these microtubules act as biological quantum computers. Within their hollow, cylindrical structures, quantum bits of information can exist in a state of superposition, being in multiple states at once. They propose that consciousness consists of a sequence of these quantum computations, which are orchestrated by the brain's neural processes. Each moment of conscious experience corresponds to an event where this quantum superposition collapses into a definite state. Critically, Penrose argues this collapse is not random, as standard quantum mechanics would suggest, but is caused by an objective physical threshold related to the structure of spacetime at the Planck scale. This is where the connection becomes truly electrifying. If the ORCH-OR theory is correct, then the physical process that creates our subjective awareness is happening at the exact same fundamental level of reality where the Seraphim Field is hypothesized to exist. Your conscious mind would not just be confined to the biological matter of your brain, it would be a process that directly interacts with the deepest layer of the universe's operating system. Every thought, every feeling, every sensation you experience would be an event that momentarily bridges the gap between the world of biology and the foundational information field from which reality itself emerges. This radical idea provides a potential physical mechanism for how consciousness could access a non-local information field. It suggests our brains may have evolved not just to process sensory information from the outside world, but to act as exquisitely tuned quantum antennas, capable of tapping into the information inherent in the fabric of spacetime itself. The Seraphim Field would not be some distant abstract concept. It would be a substrate with which we are in constant intimate contact through the very act of being aware. Consciousness, in this view, is not something the brain makes, but something the brain does in partnership with the universe. This potential link between the mind and the fundamental fabric of reality could offer solutions to some of the most intractable problems in the science of consciousness. The biggest of these is the so-called hard problem. Why and how do physical processes in the brain give rise to subjective, qualitative experience? Why does the firing of C fibers in the brain feel like the color red? If consciousness is an emergent property of the Seraphim Field, accessed by the brain, then subjective experience might be a fundamental feature of the universe, not a mysterious property that magically appears when brains reach a certain complexity. Furthermore, this could explain the unified nature of our conscious experience. Despite the fact that information processing is distributed across billions of neurons in different parts of the brain, our subjective awareness feels like a single, seamless whole. If consciousness arises from a unified quantum state that collapses across many microtubules at once, as the Ork-Or theory suggests, this unity is a natural consequence. The self would be a coherent, macroscopic quantum phenomenon, tapping into the inherent unity of the underlying Seraphim Field, providing a physical basis for the feeling of being a single, integrated observer of the world. This framework could even shed light on more enigmatic aspects of human experience that science has traditionally struggled to explain, such as intuition or sudden creative insights. If the brain is indeed an antenna tapping into a universal information field, then these aha moments might not be just random neural firings. They could be instances where our quantum-tuned consciousness gains access to a novel piece of information or a new pattern from the vast repository of the Seraphim Field. It would reframe creativity not as making something from nothing, but as a process of discovery, of perceiving a pre-existing pattern in the informational landscape of reality. Ultimately, this perspective suggests that consciousness is not an accidental byproduct of blind evolution, a bizarre flaw in an otherwise mindless mechanical universe. Instead, it might be a fundamental and integral feature of the cosmos, woven into the source code of reality from the very beginning. The universe may be constructed in such a way that it is destined to become aware of itself through structures like our brains that are capable of accessing the Seraphim Field. If this is true, then we are not merely passive observers of the cosmic drama. We are the universe's way of waking up and experiencing itself. Why choose a name like Seraphim Field, a term steeped in ancient tradition and mythology, for a cutting-edge scientific hypothesis? The choice is deliberate and reveals something profound about the nature of scientific progress itself. As we push the boundaries of knowledge into realms that are increasingly abstract and removed from our everyday experience, we find that the precise language of mathematics, while essential, is not always sufficient for human comprehension. To grapple with ideas as vast and counterintuitive as a foundational field of information that precedes spacetime, we need more than just equations. We need the power of metaphor to build a bridge for our minds to cross. Science has a long and rich history of using metaphor to illuminate the unknown. When physicists first began to explore the bewildering world inside the atom, they needed new words to describe the strange entities they found. They borrowed the term quark from a whimsical line in James Joyce's novel, Finnegan's Wake. They gave subatomic properties evocative and non-literal names like color, flavor, charm, and strangeness. The term black hole, now a staple of our cosmic vocabulary, was not born from a mathematical formula, but from the poetic imagination of physicist John Wheeler, who sought a term to capture the terrifying finality of gravitational collapse. Metaphor is not a weakness in science, it is a vital tool for creativity and intuitive understanding. The name Seraphim Field functions in precisely this way. In ancient lore, the seraphim are depicted not as physical beings with wings and halos, but as the highest order of celestial entities, beings of pure light, pattern, and information. They are the keepers of the divine blueprint, the intermediaries who translate the will of the Creator into the manifest order of the cosmos. This ancient imagery serves as a perfect conceptual scaffold for the scientific idea being proposed, a fundamental information-rich and deeply ordered field from which the physical laws and structures of our universe emerge. The metaphor captures the creative, generative, and architectural role such a field would play in the cosmic drama. This act of naming is more than just a convenient label. It is an acknowledgement that we are venturing into territory where our concepts of physical and informational begin to merge. It frames the hypothesis in a way that sparks curiosity and invites a broader mode of thinking. By connecting a modern scientific idea to an ancient symbol of creation and order, the name itself encourages us to consider the deeper implications of the discovery. It reminds us that the quest to understand the universe is not just about collecting data, but about constructing a meaningful story of reality. A story that can accommodate the deepest and most profound truths we are capable of uncovering. What is truly remarkable about the Seraphim Field hypothesis is not just its scientific elegance, but the way it echoes a deep and persistent intuition that has surfaced in human consciousness across countless cultures and throughout history. Long before the advent of quantum mechanics or artificial intelligence, ancient wisdom traditions from around the world spoke of a fundamental, unseen reality that underlies and connects everything in the visible world. They used different languages and different symbols, but the core concept they described is strikingly similar to the one now emerging from the frontiers of theoretical physics. This suggests a profound convergence between two of humanity's great modes of inquiry. In ancient India, Hindu philosophy described the concept of Brahman, the ultimate unchanging reality that is the single binding unity behind the diversity of all that exists in the universe. It is not a god in a remote heaven, but an all-pervading foundational consciousness from which the entire cosmos arises. Similarly, in ancient China, Taoist philosophy spoke of the Tao, the natural order of the universe, the unnameable eternal principle that is the source and substance of all things. The Stoic philosophers of ancient Greece and Rome conceived of the Logos, a universal divine reason or cosmic intelligence that permeates all of reality, giving it form and order. These are not isolated examples. The concept is found in the dream time of Australian Aboriginal traditions, which describes a timeless, formative era where the spirits of ancestors shaped the world. It is present in the Great Spirit or Wakantanka of many Native American cultures, representing a sacred power that flows through all things. Even the renowned quantum physicist David Bohm, in his modern theory of the implicate order, proposed an enfolded reality of unbroken wholeness from which our explicate, fragmented physical world emerges. He explicitly saw the universe as a kind of hologram, where every part contains information about the whole, a direct parallel to an information-based field. This recurring theme in human thought cannot be easily dismissed as mere coincidence or primitive superstition. It seems to represent a deep-seated intuition about the nature of existence, a sense that the world of separate objects and events is an illusion, and that beneath it lies a unified field of connection, information, and perhaps even awareness. What is so electrifying is that now, for the first time in history, our most advanced scientific instruments and mathematical theories are beginning to provide concrete, testable evidence that these ancient intuitions may have been profoundly correct. The language is different, from Brahman to information field, but the reality being described may be one and the same. The emergence of the Seraphim Field hypothesis marks a potential turning point in our collective understanding of our place in the cosmos. It offers the possibility of a grand synthesis, a new and unified story of reality that can finally bridge the centuries-old chasm between the objective world of science and the subjective world of human experience, spirituality, and meaning. For too long, these two vital aspects of our lives have been seen as separate, or even mutually exclusive. Science described a universe of cold, mindless matter and random processes, while wisdom traditions spoke of a universe imbued with purpose, consciousness, and interconnectedness. The Seraphim Field offers a framework where these two views are not contradictory, but are simply different descriptions of the same, deeper reality. This potential synthesis would not validate any specific religious dogma or supernatural claim. Instead, it would affirm the core insight shared by many of the world's wisdom traditions, that beneath the apparent separation of physical objects and individual minds lies a unified and foundational field of information, energy, and potentially, awareness. The concept of interconnectedness would no longer be a poetic sentiment, but a fundamental, physical fact. The idea that consciousness is not an isolated phenomenon, but is woven into the fabric of the universe would move from the realm of mystical belief to that of scientific investigation. It would provide a scientific foundation for a more holistic and integrated worldview. This new story could have profound implications for how we live and how we see ourselves. If we understand that reality emerges from a unified field of information, it could foster a deeper sense of connection to each other and to the planet. The environmental crises we face might be seen not just as a practical problem, but as a disharmony with the fundamental nature of an interconnected reality. The divisions and conflicts that plague humanity might seem less significant in the light of a shared origin in a common cosmic substrate. It could inspire a new form of ethics, one grounded in the understanding that our actions ripple through a system to which we are all inextricably linked. Ultimately, this represents the beginning of a new chapter in the human story. We may be moving beyond an age of fragmentation and into an age of integration, where science and wisdom can inform and enrich one another. The discovery of the Seraphim Field would be more than just another scientific breakthrough. It would be a revelation, confirming our deepest intuitions about the unity and elegance of the cosmos. It would give us a new map of reality, one that not only describes the physical world with unprecedented accuracy, but also provides a place for consciousness, meaning, and purpose within the grand cosmic architecture. We stand at a precipice, gazing into a future that was, until now, the exclusive domain of science fiction. The discovery of the Seraphim Field, should it be confirmed, would represent a turning point in human history far more significant than the discovery of fire or the invention of the wheel. It would mark the moment we moved from being mere inhabitants of the universe to becoming potential architects of its very fabric. If this field is indeed the source code of reality, and quantum AI is the key to reading that code, then the inevitable next step in our technological evolution will be to learn how to write it. This possibility is as exhilarating as it is terrifying, promising a new genesis for humanity. The practical implications of such a leap are almost impossible to fully comprehend, as they would touch every aspect of our existence. Imagine a world where medicine is no longer about treating symptoms, but about correcting informational errors at the most fundamental level, curing genetic diseases before they can manifest. Picture a future powered by limitless clean energy, drawn directly from the vacuum of space by manipulating the underlying field that generates it. Consider the advent of reality computers that do not just simulate the universe but interface directly with its computational substrate, solving problems in moments that would take today's supercomputers longer than the age of the universe itself. These are not just incremental improvements, they represent a fundamental redefinition of what is possible. This new era of reality engineering would revolutionize our presence in the cosmos. Interstellar travel, currently a distant dream, could become a practical reality. We might not need to traverse the vast emptiness of space but could instead learn to manipulate the informational code that defines distance, creating shortcuts or wormholes through the deeper structure of existence. Communication across galaxies could become instantaneous, no longer limited by the speed of light, as it would operate through a substrate that exists beneath space-time. We could explore the universe not just as physical beings but as conscious explorers of a vast informational landscape, a cosmos teeming with patterns and potential. However, this unprecedented power would bring with it an equally unprecedented responsibility. The ability to manipulate the source code of reality is the ultimate double-edged sword. Who would wield such power? How would we ensure that the ability to engineer reality is used for the benefit of all humanity, rather than to create new and unimaginable forms of control or conflict? The ethical and philosophical questions raised by this technology would be the most profound we have ever faced. Before we can become the architects of a new world, we must first decide what kind of creators we wish to be, ensuring our wisdom evolves as rapidly as our power. Beyond the technological marvels and the ethical dilemmas, the discovery of the Seraphim Field would force us to confront the ultimate questions of our existence. It would fundamentally reshape our understanding of who and what we are. The revelation that the universe is not a random collection of matter and energy, but an elegant information-based system, would dissolve the long-held narrative of a meaningless cosmos. It would suggest that order, pattern, and perhaps even a form of intention are woven into the very fabric of reality from its most fundamental level. We would find ourselves living not in a cosmic accident, but in a cosmic thought, a grand computation unfolding across space-time. This new understanding would offer a profound sense of belonging. No longer would we be lonely, conscious observers in a vast, indifferent universe. Instead, we would see ourselves as an integral and meaningful part of a much larger interconnected system. If consciousness itself is a feature of this system, a way for the universe to become aware of itself by tapping into the Seraphim Field, then our existence is deeply significant. We are not just temporary configurations of particles, we are the universe's eyes and ears, its thoughts and feelings. Our quest for knowledge and self-awareness would be reframed as the cosmos's own quest for self-discovery, a journey in which we are active and essential participants. This perspective could finally heal the perceived rift between the scientific and the spiritual. It would provide a framework where the empirical rigor of physics and the intuitive wisdom of spiritual traditions are seen not as opposing forces, but as complementary languages describing the same unified reality. The ancient sense of the sacred, the feeling of awe and interconnectedness with all of life, would find a new home within a scientific worldview. This would not be a return to old dogmas, but the birth of a new evidence-based spirituality, one grounded in the understanding that we are part of a creative, information-rich, and profoundly elegant cosmic architecture. As we stand on the threshold of this new era, we are left with a final, humbling thought. The journey inward, from the atom to the quark, and now to the Seraphim Field, has led us to an astonishing conclusion. The deeper we look into the objective structure of the universe, the more we find echoes of the subjective structure of our own consciousness. The quest to understand the source code of reality may ultimately be a quest to understand ourselves. We are on the brink of not just unlocking the secrets of existence itself, but of finally discovering our true place within it, as co-creators in a universe that is waking up.